Hi! In this tutorial, I will first show you how to find the ground state spin configuration given a certain lattice, and then given that same lattice, how to calculate and then plot numerically the spin wave dispersion. Okay, so to start, we need a lattice. For this, let's use a simple ferromagnetic 3-chain. So let's first create our lattice specifying the unit cell. And let's make this 3-chain along the x-axis, for example. We can put some iron atoms at the origin of each cell. And these terms right here, dx, dy, dz, specify the single ion anisotropy. They align the spins along a certain axis. So let's align these spins along the y-axis and generate our lattice. Great, but we're going to need some bonds here. So let's go to bond creation and create a bond. Remember that this bond will be propagated through the entire chain, and so we only need to make one. And so we set a ferromagnetic interaction, so we use the identity matrix. Click OK, generate. Great, now all 3 atoms are now bonded together. So this is now where we will export this configuration, this lattice configuration, for the simulated annealing process, which will in turn return the ground state spin configuration. So the first step is to save this lattice configuration. To do this, in the magnetic cell window, click the Compute menu and go to Export for Monte Carlo. You can leave this size 3 here. This just tells the simulated annealing process how many times to tile the interaction cell around itself as to get the right interactions of the atoms and find the correct spins. 3 will do just fine. Okay, and so now we need to save this. I already have a preloaded file here, it's montecarlo.txt. Great, and so now we need to launch the simulated annealing process. To do this, again go to the Compute menu and click Launch Simulation. We need to specify this lattice configuration file, so this Monte Carlo. Great, so now we can just run the simulation, and it will basically write to that spins file what the spins should be. And so now we can load those spins onto our model to see what they look like. To do this, go to the Compute menu and click Load Spins from File. Scroll down, get our spins file. Here we are. All of our spins lined up along the y-axis, just like we specified. Great. Well, so that's really it for spins. You can do this for a bunch of different lattices. Right now we have tested for chains, cubes, all sorts of anisotropies in different directions and things like that. You can do simple cubes, body-centered cubes, face-centered cubes. So please try and do as much as you can. For now, let's go on to spin wave dispersion. To do this, once again, go to the Compute menu and click the Perform Spin Wave Calculation. Okay, so now 2 windows appear. The little one is the one we want first. We need to specify the interaction file and the spin file again. So let's find our montecarlo.txt file and our spins file. Note that once we selected those files, text appeared in this spin wave file editor. And so what this is just a basic text editor that will allow you to make any changes in your spins file or your interaction file. And so you can make those changes on the fly, so we can just, let's rewrite that and save it. Great, so that change has been saved. So now this spin wave dispersion calculation requires a scan along a certain direction, and so we need to specify that direction and how many steps that scan should take. So since our chain is in the x direction, let's also make our scan in the x direction so we get meaningful results. Let's specify 50 steps, sounds good, and once we click OK, 2 things will happen. This will spawn 2 parallel processes. One that will find the analytic form of the eigenvalues that we seek, and the other will evaluate those eigenvalues numerically and plot them. And so once we click OK, we can see that reflected in this processes window down here. Great, so we hit OK. now it has spawned two processes, the first and the second. So here we go. The first is this dispersion eigenvalues box. It shows the analytic form of these eigenvalues formatted in LaTeX. Right now it's using AMS format, so if you're trying to use RevTech for example, these M boxes here might throw some warnings. But so you can just cut and paste this right into any text file, and it should work quite well. The second window that shows up are the numerical evaluation of those eigenvalues and plotted them. And yeah, that's about it. So thank you for watching, and stay tuned for some